So before going to explain the types of types of polygons, just see that identify that sides, vertices, angles and diagonals from that figure. Okay, so sides from that given figure, just say that if you know that sides, then you also write down. Okay, sides here AB, next BC, CD, DE, next EA. So how many sides are there in all? Here we have that 5 sides. 1, 2, 3, 4, 5. Here we have that 5 sides. Next vertices. Tell me that vertices here. A, B, C, D, E. Already we know that the number of sides is equals to number of vertices, right? So here we have that how many vertices? Yes, we have here 5 vertices. Next angles. Angle A, angle B, angle C, angle D and angle E. So here how many angles are there? Yes, 5 angles, and we know that number of sides is equals to number of vertices is equals to number of angles. So here all are equals to 5. Now come to that diagonals. Now identify here diagonals. Diagonals means a line segment which joins two non-adjacent vertices only, no? So A, B, those two are adjacent vertices. So that is a side, that is not a diagonal. So here AC. So one of the diagonal is AC and the one is AD. Okay. Next take that B. So BE and the one is BD. Clear? And the next one is CA. Already CA completed. Okay. So another one is CE. Okay. CA, CE. Next come to that D. DB, DA. DA completed. DB also completed. So no need to write it again. Next take that E. EB, EC. EB or BE. EC or CE. Those two also same only. Okay, in totally we have that how many diagonals here? Here also we have that 5 diagonals. How many diagonals are there? 5 diagonals. This is somewhat different. Here in this case here number of sides is equals to number of vertices is equals to number of angles is equals to number of diagonals. In this case only. Okay, but in every case it is not possible, means that is not possible. Number of diagonals is too different than that remaining 3. Okay. So here see that next types of polygons. Here the first type is convex polygon. Okay, here we have the 2 types of polygons. One is convex, another one is concave. So see here about that convex polygon. What about that convex polygon means? If all that interior angles, which means each interior angle of a polygon should be less than 180 degrees. Okay, should be less than 180 degrees. Those polygons we will call it as convex polygons. Okay, so here see that here we have that some interior angles. No, how many interior angles are there here? Here we have that how many interior angles are there? 5 interior angles. No, here just observe that all that interior angles, each interior angle is less than 180 degrees. Actually 180 degrees means a straight line, right? On a straight line at that point, common point, straight angle will be formed. What is that straight angle? That is 180 degrees. So 180 degrees means that is a straight angle formed on a straight line. Okay, so that angle must be less than 180 they are saying. So here to here any angle, here to here any picture is there means that one we will consider it as convex polygon only. Okay, this is not a straight line, right? So here this angle is less than 180 degrees only. Okay, that's why here just observe that this is also less than 180 and this is also less than 180. Here these are not a straight lines, no. That's why obviously those all angles are less than 180 degrees only. So this type of figures we will call it as convex polygons. Okay, now concave polygons means what? Okay, see the difference here. What is that? A concave polygon means if at least one of the angle of a polygon, if at least one of the angle of a polygon, either that is interior angle or exterior angle, okay, any one of that angle of a polygon is greater than 180 degrees, which means see here. Okay, so observe here. Not exterior angle, here observe that interior angle, this is less than 180, this is less than 180 and this is also less than 180 and this is less than 180, here also less than 180. But here when you draw here one of that straight line, this is that 180 degrees. So this angle is greater than 180, here somewhere small place is there, no? So that angle is greater than 180 degrees there. Okay, so this type of figures we will call it as concave figures or concave polygons. Okay, just see that what is the difference between convex polygon and concave polygon. Here this is that convex polygon. Okay, this is that convex. Okay, why? Because here each interior angle is less than 180 degrees. Okay, here directly we can take here angle is 90 degrees, no? So that is less than 180 degrees. So here each angle is less than 180 degrees. That's why we are calling that angles are, sorry, that polygons are convex polygons. So I draw here one, I will draw here another one. Just observe that that is also a polygon, right? Why? Because that figure is made up of line segments and that is a closed figure. Okay, that's why we will call this one as a polygon. And this is which type of polygon? Yes, that is a concave polygon. Why? Because here angle is more than or greater than 180 degrees, no? That's why we will call this polygon as a concave polygon. Okay, so simply each interior angle of a polygon is less than 180 means convex, and at least any one of the angle is greater than 180, then we will call that polygon as a concave polygon. Okay, so this is the difference between those two polygons, and these two are the types of polygons. So here in that convex polygons, the first one is equiangular polygon. Equiangular polygons. Second one is equilateral. Equilateral polygons. Next one is regular polygons. Okay, here we have that three types of convex polygons. So what is that first one? Equiangular. In that name only they given that equiangular. So in that polygon all angles are equal. All angles are equal in a polygon. Okay, in a polygon here all angles are equal. So which one we can take here? For example, which polygon we can take for that example of equiangular polygon? Yes, just observe that rectangle. Here they are saying that equiangular. Here this is 90 degrees, 90, 90 and 90. From childhood onwards we are learning that, right? In a rectangle all angles are equal. So here the example is a rectangle. Okay, now come to that equilateral polygons. Here lateral means sides. Okay, so equilateral means equal sides. All sides are equal. all sides are equal in a polygon. Okay, all sides are equal of a polygon. So here which one we can take for that example? Okay, here we can take that square. Okay, here what is that example? Square. Why? Because in a square all sides are having that equal length or not? All sides of a square is having that equal length only, no? That's why we can say that square is an example for equilateral polygon. Next, regular polygons means what? Here just observe that equiangular means all angles are equal, and here equilateral means all sides are equal. Now the combination of these two, okay, we will get that regular polygons. So regular polygons means all sides are equal, and all angles also equal. Okay, in this case only angles are equal, here only sides are equal, but here come to that regular polygons, here all sides are equal as well as all angles also equal. Here we can take that square is again example for this one. Why? Because a square is an example for that regular polygon means here in a square all sides are of equal length. So satisfying or not? Yes. And come to that angles, here this is having that 4 angles and also having that all are of equal measures. So this square is having that all angles are equal. So this is satisfying that those 2 points are not. Okay, that's why we can say that square is an example for regular polygons. Some other regular polygons also there. What are these? Okay, regular hexagon, regular pentagon, regular nanogon, some other. Regular means all sides are equal and all angles must be equal. Okay, so this is that. These all are the types of convex polygons. Okay. So after that, here by taking one line segment, is it possible to form a polygon? No, it is not possible. By taking one line segment, is it possible to form a polygon? Okay, here this is not possible. Why? Because this is that there is that line segment. Okay, closure figure which is made up of line segments. Okay, closure figure which is made up of line segments, that is known as a polygon. But here they are saying that only one line segment. By taking one line segment, we cannot form that any polygon. Okay, by taking two line segments, so I taken like this two line segments. Is it possible to draw that? Is it possible to form any polygon here? No, this is an open figure. Why? Because this is that starting point and this is that ending point. Okay, is it possible to form here any polygon? No, not possible. Okay, now by taking that three line segments I can form here one of that polygon. What is that? I taken like this. Okay, so this figure is having that how many line segments? 3 line segments. So that is a closure figure or not? Yes, that is a closure figure. And this closure figure is made up of line segments. That's why we will call this figure as a polygon. Okay, so here the polygon which is made up of 3 line segments. Okay, so we will call this one as a triangle, right? So minimum number of line segments required to form a polygon. Okay, that is my question. So here minimum number of line segments required to form a polygon, that is 3. Okay, by taking one line segment we cannot form any polygon. By taking two line segments also we cannot form any polygon. By taking 3 line segments we can form one of that polygon, that is a triangle. So that is also a polygon, no? So that's why here minimum number of line segments required to form a polygon, that is 3. Maximum is your wish. Okay, maximum infinite. By taking infinite number of line segments we can draw that different pictures. Okay, so minimum number of line segments means must be 3 line segments required. Okay. So here next say that a number of line segments and a name of a polygon. If that figure is having that 3 line segments, then what is the name of that polygon? If that figure is having that 4 line segments, then what is the name of that polygon? Okay, so the type of names we will learn here, see. So if that minimum number of line segments must be required, 3 only, no? So if that polygon is consisting 3 line segments, we will call that one as a triangle. So name of that polygon is triangle. Okay, if that polygon is consisting 4 line segments, then we will call that one as a quadrilateral. Okay, so quadrilateral means a 4-sided figure. Quadrilaterals we can take example as a square, rhombus, rectangle. These all comes under quadrilaterals. Okay, next, if that polygon is having that 5 sides, a 5-sided figure, that is a pentagon. That is a pentagon. Next, 6 sides, that is hexagon. Okay, next 7 sides, that is a heptagon. This is having another name, that is a septagon also. Okay, next, if that polygon is having 8 sides, 8 line segments, then that is called octagon. Okay, and the figure is having that 9 sides, we will call that one as a nonagon. Nonagon. And 10 sides, 10-sided figure is there, we will call that one as a decagon. Okay, and so on. Okay, we know we have that so many names, but up to here, up to 10, that is sufficient in this class. Okay, next we will have that dodecagon, tridecagon, like that, 2 different names there. So no need to learn all those. So 3-sided figure is there, we will call that one as a triangle. 4 sides there means that is a quadrilateral. 5 sides there means that is a pentagon. And 6 sides is there means that is hexagon. 7-sided figure is known as a heptagon or septagon. 8-sided figure is known as octagon. And 9-sided figure is known as nonagon. 10-sided figure is known as decagon. Okay, these all are that names of a polygon. Okay.